Although we've been using the mouse in our examples, we've only really been using the click event and not really using other input that's available with the mouse other than which button we might have clicked. But we get a lot more than that by looking at the position of the mouse and then being able to use that position in our either to design things by giving, say, using those positions to determine vertices, as we'll see in some examples, and various kinds of interactive and CAD-like applications. Now, what we've got to do is worry a little bit about now what that position really means, because now we have to worry about conversion of whatever coordinate system the screen is using, which we're going to talk about, and then converting that back to application coordinates of some sort. Because of the application, we've said one of the big advantages of modern graphics systems, they allow you to work in the units of the application. On the other hand, if we look at the canvas positions are going to be given to us in pixels, and we're going to have to worry about that conversion. We also want to talk about related things we can do with the mouse a little bit, such as resizing or reshaping the canvas by pulling a corner of it and making it bigger or smaller, or change, and also as part of that of changing the height to width ratio or the aspect ratio of the canvas. So let's first look at the window and just say, well, the window system origin is in a different place. So there's two things you have to look at. One is the size of the canvas, which we specified back when in our initialization in the HTML file, we said what size initial canvas do you want, but we also didn't talk about what its origin was in its own coordinate system. And it turns out that origin, unlike what we do in most applications, isn't at the bottom left corner of the rectangle. It's in fact at the top left. Now that's an artifact of how television displays were first done. They were done, well, they're still done that way, but it goes back historically to that, where the display on a television is generated from the top to the bottom, actually from the top to the bottom, and each line that is displayed on a television is displayed from the left to the right. So it's natural to talk about what are called scan lines that you see on your television, and those lines are usually numbered starting at 0 and down to whatever the resolution of your television is, starting again at the top left. So we have that problem, and that problem has gone on to the reason it is a problem is because in all of the Windows system literature, where you're now worried about what happens on the display device, you're using coordinates that are based on that. And so what's returned from a mouse is historically and still based on that, having that origin at the top left. Now, if we do have a pixel-oriented display, a discrete display, and we give it a height and a width like we do with our canvas and with our viewport, then we could say, okay, the top left corner is pixel 0, 0, and the bottom right corner is pixel W minus 1, H minus 1, where W and H are the height, and with a width and the height. So if I give you a position in the screen or window coordinate systems, X, W, YW, then I have to convert that, if I'm going to use it in the application, back to whatever system I'm using in the application. So the simple one we've been using so far is clip coordinates. Remember, the clip coordinates went from -1 to 1 in the X, Y, and Z direction, but because we're dealing with two-dimensional issues right now, because what comes back from the display is two-dimensional, we can assume that Z is going to be 0. We don't have to worry about it for now, but what we have to do is worry about how we convert XW and YW. So if you look at what's happening is that if you look at the window, then we want to go to a window where this corner is at -1, and this upper right corner is at 1, 1. And we could look at it independently in the X and the Y direction, say, okay, so you want something that goes from 0 to W minus 1 now to be mapped into variables that go from -1 to +1. So we can look at that map this way. And if we look at it as being continuous for now, so let's not worry about the fact that W and H are discrete, and so they're the numbered 1, 2 up to 0, 1, 2 up to W minus 1, and 0, 1, 2 up to H minus 1. Then the mappings you're worried about in floating point are you want to map 0H to minus 1, minus 1. That's the in the X direction. And in that top corner, W0 is going to match to 1, 1, the top right of the window in our clip coordinate space. Now this will have to vary if you're using a different size window in your application, but it's basically the same idea. You look at whatever your window is here in your application, and then you want to map these values this way separately in X and Y, and these are the mapping transformations. And you can see that what happens is when xw is 0, this is minus 1, and when xw is equal to w, then this is equal to plus 1, and likewise. Now for the y, it's a little bit different because you have to move the origin from up here to down here. So all of the y values essentially have to be inverted. So if you have a y value, you want to subtract it from the maximum value, the height, and then use that value, so you have this flipping that occurs over here. So if we now get a position back from our event listener, then somewhere there we're going to build in this coordinate conversion, and we'll see that in the next couple of slides. So we look at again at the HTML file and at the JavaScript file. So the canvas is going to be, let's assume, was specified in the HTML file to have size canvas width by canvas height, and what we get back from the mouse event, the mouse clicking, are now additional variables that we're going to look at, client X and client Y, that come back with this event. So it's sort of a click event. It's also going to return, that's going to generate this object event, and within there are now client X and client Y. So here's just a very simple example where we're going to use in some of the examples I'm going to show you in a minute, where what we do is, here's the event listener now. It's listening for a click event, and the function it's going to execute when it gets that event is it's going to take the value of where the mouse is, translate that into the application or clip coordinate system in our example, and then put that value onto the GPU so we can display it. Our first example will just be displaying little boxes wherever we click the mouse. So we set a variable over here, which is a vec2, which does that transformation. We get back client X and client Y. We have the canvas width and height, which we started with. We're not worrying about resizing the canvas yet. And then these are just those two equations that we had before, using the event to return the variables in the canvas size. Then what we do is send that information down to an existing buffer that we set up on the GPU, and so we send a vec2 down there, which is just this value that we computed back up here, and if we're adding it to a list that's in the GPU. So we're assuming here, and you could see that in the code in the example, that we made a big enough array on the GPU to hold it, and we started off with no elements in the array, and each time what we do is every time I click the mouse, I add another vertex to the array that's on the GPU, and then I display it in the normal way by just doing a draw arrays on that array with whatever the size of index is at that time. So let's look at a bunch of examples that I have up in the chapter 3 code, and I start off with an example square that I'll show you in a minute, that simply takes the position of what's a little colored square in there. One thing that you can look at is you'll see in there is that it uses a GL point size built-in attribute. Again, there are very few built-in attributes that are left in WebGL from the original OpenGL. That's one of them, and that allows you to specify the size of a point when you render that point. The default is to, when you render a bunch of vertices as points, is to put out a single pixel with whatever color you set, but you can make that bigger by setting that GL that GL variable, and I've set it, I forget what it is in the code, but it just makes it a little more visible. Second example I'm going to show you is storing the mouse clicks so that you can define a triangle strip. So the first 3 clicks you need to get that first triangle, but then with a triangle strip, each successive mouse click is going to generate another vertex that will be combined with the last 2 to get a new triangle at the end of the strip, and I'll show you that. Then I'm going to extend it a little bit to 2 applications I call CAD1 and CAD2, and the reason I'm calling that is that they have a lot of the properties that you have to worry about if you're doing some CAD-like or painting-like application. You want to be able to put objects in, and objects we've said are going to be defined by vertices, and the vertices are going to be entered by the mouse, and you can then extend that to how you do painting kinds of applications. And I have some menus in there so you can do things like use what we did in the last lecture to select colors. So let's look at those applications for a minute. Okay, so here's the chapter 3 again, and the first one I said we're going to look at is square. And so square, I made the clear color gray so you can see the size of the canvas, and you can also now see everything on the background. So I click here and I get black. What I'm doing here is cycling through the eight basic colors we use, red, green, blue, cyan, magenta, yellow, black, and white. And all I'm doing is cycling through them. Actually, I'm not even using white. I'm just using 7 without the white, and there, every place I put the mouse, it puts on. So it just shows you that you have to do that coordinate conversion because 0, 0 is up here, and then converting it into the coordinates from -1 to 1, 1, and clip coordinates. So that's a very, very simple example, but notice it does have this nice interactivity to it. You can also do other versions where you hold the mouse down and you continually look at the position, not waiting for a click, and then you have the elements of what would be drawing a line or a curve. Okay, let's look at the next one. Triangle, this is the one we say, okay, we're going to have to start with 3 clicks, so nothing happens for the first, nothing happens for the second. Here comes the third. Now in this one, what I'm doing is assigning one of the colors to the vertices, but instead of making the entire triangle one color, just say using the first vertex to determine the color of the whole triangle, I'm using interpolation of the colors at the 3 vertices, and it draws a nicer little thing. Now I have a 4th one, so it's being combined with the previous 2 vertices to get this one, and then I keep going on here. And I could actually do a sort of painting-like application here with that. So that's kind of cute. It's very, very simple. You're just taking the positions and adding them on to an array that has some maximum size. So that's kind of pretty little application. Okay, so now let's look at the things I call CAD1 and CAD2. Let's see, they're up here. So here's CAD1. And notice now I'm going to let you pick the color through a menu, through those 7 colors. And what I'm going to do is now use each pair of mouse clicks to specify the main diagonal of a rectangle. So first click, second click, I'm in black now. If I want to change colors, I can just click here. I'll make the next one red, and so on. So just same kind of thing. The difference here from the point of view of developing a CAD-like or painting-like application is you have to do something about storing intermediate values because it's pairs of vertices that I care about rather than each successive vertex is going to cause some sort of a drawing. Okay, now I extend that a little bit here to say, well, this is pretty simple because all you have here is a rectangle, so that's not very exciting. So let's go one step further and say in CAD2 here, what we do is allow successive vertices to keep defining a polygon. So you can have a polygon of any number of vertices, but we have to say, well, where do you end one and start the next one? So I have a button here to allow you to do that in the same color menu over here. So I should be able to start like this. I'm putting things in. Now I want to end that, and there's the first polygon that I've defined. Let's change the color and do another one over here, and I can end it over there, and so on. So now we're getting closer to perhaps a useful application. Now you have to keep track of some arbitrary number of polygons, vertices, although I'll put an upper limit to that in my code. And also I have to have some sort of a triangulation scheme in there, which we discuss in the book, so that I can render this, because all OpenGL and WebGL know how to do is render triangles. So in here is something that will correctly divide this polygon into triangles for rendering. Maybe not the best ones, but there's no lighting here, so everything comes out fine. And if you do things like this, let's see what happens if we do a non-simple polygon. Go here, 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 end the polygon. You see, you get something out. It may not be what you want. Remember, I went from this vertex to this vertex to this one to this one, and my triangulation scheme happened to give me this, but it's a non-simple polygon that we discuss in the book, and we'll probably discuss later in these lectures. Okay, so let's go back and add one more thing that we can do with mouse positions today. So let's talk now for a minute or two about window type events. So events can be generated not only by the mouse directly, but also in terms of other things that are happening and things that might be happening outside of your own WebGL application. So you can have multiple, let's say viewports, so that the canvas element, you're only using part of it for your WebGL application, but other applications may be operating in different windows. You have this complex environment. You also have this environment that with the browser, that you may have multiple browser windows going on. And so what happens is you can move windows around, you can change the size of windows, you can open a new window, and every time you do one of those things, you have to say, well, how am I going to respond to that? If you think in terms of events, those are window kind of events. I can iconify a window, so all of a sudden it gets replaced by an icon. What do I have to do? Well, some of the things I have to do is for the windows that are now visible, I have to draw into those windows. So these window events require me to take some kind of action. Now, for a lot of those, there are default callbacks, because if you have to supply callbacks for all of those things that kind of routinely go on in this multi-window environment, that's a lot to ask for. So there's usually reasonable callbacks, but when we're doing things in graphics, in WebGL, and CAD, we have to look a little bit more carefully at this. But one of the things to note too is that as soon as I open a window with my canvas and it's a WebGL window, automatically there needs to be an event that says, okay, what do I put in that window initially? So there's this initial thing that at least minimally you should be putting the background color, clearing the screen in the background color. Okay, but let's look at one that says what happens with the mouse, and I take the corner of that window and I move it. So I get a different size window that might have different height to width or aspect ratio. What do I do? Well, that gets very complicated when you're displaying geometry within that window, and you have to make some sort of decision about that. That's called a reshape or a resize event, and you've got to put something in that window when it's resized. Well, you have two fundamental options. One is that you display the same objects, but you change the size. This would be saying, well, I'm looking at this scene, I still want to see the whole scene within this new resized window. But then you can say, well, what if it's more like, say, you're inside of a room and you're looking outside through a window, which is kind of the analogy where we get the terminology from, and say, what if that window were bigger or smaller? If it was bigger, I'd see more of the world outside of that window, and if it was made smaller, I'd see less of that of the world. So you have to choose between those two options, and that's why generally applications, real applications, will always have a resized event listener in them to say, for this application, this is what I want to do. But one thing that's common to almost all of them is at least you want to keep the proportions. if I go from a square window to a rectangular window, I really want to at least have the objects that are redisplayed to have the same proportions that they had before. So for example, if you had a square, you still want the square, whether it's bigger or smaller, to still be a square. If you had a circle, you don't want that circle changing to an ellipse, usually. So we have to do something within our own listener to do that. So let me give you one example of that and show you how you develop those resize listeners. So this is called whenever you grab a corner and you change the size of a window, that's called a resize event, and you can say on resize, then do the following, and what you use is the size of the new canvas, which is called inner height and inner width. If you ever need to know the size of the canvas at the present time, because it might not have been the canvas width and the canvas height that you started to, you can always look at those variables, inner height and inner width, to get it, and then use that to do what you want in your particular example. Now, what I'm going to do is show you a final example on the next slide, which says, well, what if we just want to keep the window square? We started with it square, let's try and at least keep it square. And the way we do that is to look at the minimum size of the inner height and the inner width, and allow that to determine the height and the width of the new canvas. So here's what we do here. We look at whether inner height is bigger or smaller than inner width, and set the minimum to whichever one it turns out to be. And then we look at that compared to the canvas height and the canvas width, and we set a new viewport. Okay, so the way to do that is to not change anything in the application except the proportions and the size of the window that we're looking at. So we're changing this to have a new X and a Y starting point and a new height and width that are based on this minimum. See, here's where it's saying that it's square. So this is just one thing that you can do, and I think just to remember for now that you're talking about the on resize event here.